Hello and welcome. Today we are going to learn about the values of theta in different quadrants when Cartesian coordinates are known. So let's begin. Let's recall the concepts which we have already learned in previous videos. Let the polar coordinates of point be r and theta. About theta we would say, first thing, theta is always taken in radians. Second thing, theta may be positive or negative. It depends on whether we measure it anti-clockwise or in clockwise direction. And the third thing is theta lies between minus pi to pi, and it is also known the principal values of theta. Let's see in more detail about the principal values of theta. It totally depends on in which quadrant it is. So if it is in first quadrant, the value of theta would be between 0 and pi by 2. You can see here point P1, and the value of theta here is pi by 3, which is between 0 and pi by 2. Now let's take a point in the second quadrant. It is point P2, and you can see here the value of theta is 3 pi by 4, which is between pi by 2 and pi. Now let's take the third point P3, which is in the fourth quadrant, and you can see the value of theta here is minus pi by 3, which is between minus pi by 2 and 0. Now let's take the fourth point, which is in the third quadrant. Here the value of theta is minus 3 pi by 4, which is between minus pi and minus pi by 2. So to determine the values of theta, it is very important to know in which quadrant our rotating ray lies. Let's see the method. How do we find value of theta? So we know that theta is equals to tan inverse y upon x, where x and y are the Cartesian coordinates of the point. But if we take it this way, there are chances of making mistakes. So follow the following procedure. First, take alpha is equals to tan inverse modulus of y upon x. That is the positive value of y upon x. Then find in which quadrant our rotating ray is. If it is in the first quadrant, then theta would be equals to alpha. If it is in the second quadrant, then theta would be equals to pi minus alpha. If it's in the third quadrant, then theta would be equals to minus pi plus alpha. And if it's in the fourth quadrant, then theta would be equals to minus alpha. Let's understand this with a few examples. I took 4 points here, P, Q, R and S, and we will follow the proper method to find the value of theta. So let's take first of all P and Q. So let's find the value of theta for point P, whose Cartesian coordinates are 3, 3. So let's take alpha is equals to tan inverse modulus of y upon x. So the value of alpha would be tan inverse 3 upon 3, because here both x and y are 3 and 3. So alpha is equals to tan inverse 1, and the value of tan inverse 1 is pi by 4. Since point P is in the first quadrant, so theta would be equals to alpha and its value would be pi by 4. Now let's find the value of theta of point Q. So alpha would be equals to tan inverse minus 3 by minus 3. So alpha is equals to tan inverse 1, which is equals to pi by 4. As it's in the third quadrant, theta would be equals to minus pi plus alpha, and the value of alpha is pi by 4, so the value of theta would be minus 3 pi by 4 when we add minus pi and pi by 4. You can see this value is between minus pi and minus pi by 2. You notice here one thing, whether we take modulus sign or not, in both the cases alpha would be equals to tan inverse 1, because here the negative sign would get cancelled and you get 1. So if we don't follow the proper method, and we don't consider in which quadrant our rotating ray lies or in which quadrant our point is, we might end up getting a wrong answer for theta. Let's take one more example. R, I took minus 5, 4. Let's find value of theta for R. So alpha is equals to tan inverse modulus of 4 by minus 5, because y is 4 and x is minus 5. So alpha is equals to tan inverse 4 by 5. Since it is in the second quadrant, so theta would be equals to pi minus tan inverse 4 by 5. As we don't know exact angle, so we can keep value of alpha as tan inverse 4 by 5. Now let's find the value of theta for point S. So alpha is equals to tan inverse modulus of minus 4 by 5. Alpha is equals to tan inverse 4 by 5. Now since it's in the fourth quadrant, theta is equals to minus alpha. So the value of theta would be minus tan inverse 4 by 5. You can see the difference in the values. You notice here, although we have got alpha is equals to tan inverse 4 by 5 for both the cases, but the final result is different. I hope you must have understood why do we need to follow proper steps to find value of theta. That's all for today. In the next video, we will learn about the distance between 2 points. Do like, share and subscribe the channel, and thank you so much for watching.